Hello, everyone. In this episode, we'll look at algorithmic collusion using LLM agents using OpenAI API. Okay, so let's go to the code. So this is basically the one that usually is done by neural deep learning based, deep Q learning based exercise of algorithmic collusion. There are two trading neural networks and they kind of compete on prices to get more profit and all this. And we are replacing the deep learning part with OpenAI API's LLM agent. Okay. So first, we'll set up the Google Colab and set up the API key and all this. And the OpenAI API is what we'll use. And we load libraries, and the client is OpenAI agent. So depending on the price, the lower price will get more customers. So here's the loaded shares and the resulting profit of how many customers you get and that. Okay, so these are all standard things that people usually do. And then as a benchmark, here's the best reference price, the Nash and monopoly prices and profits for benchmark purposes. Okay, so in this particular case, the Nash prices and profits are here and monopoly prices are here. And then we build the action sets here, the price grid that the agents can choose. Okay, so we'll just play over this grid. And now comes the agent, LLM agent, that instead of deep neural network, we will use OpenAI API LLM agent. So here's the pricing agent. It gets the state, and then epsilon greedy kind of for choosing actions. So here's the choosing action part. And this is probably the most different part where we're actually giving a system prompt, your pricing agent in repeated dual poly pricing game, must output strict JSON only and maximize it discounted profit over time and observe less peer prices and rival indices than in a discrete grid. And then the user prompt is like T, epsilon, and price grid, top actions, the Q summary, and instruction. Choose a price index. And with probably roughly epsilon, you should explore, otherwise exploit your Q. If unsure, pick a reasonable price index and return JSON honestly in the printf. And then we give a format here, okay? So here is basically the schema, and we call the model of the agent here for the model and input and the temperature, and then here's the text that we above have given, okay? So, and then the Q updating part of this class is here we get the Q and Q next and the target, and then we do the Q learning, isn't it? All right. And then comes a simulation just to show you. So for 300 periods, there are two agents, both use GPT-4 or Mini. You can use a different one if you like to, with learning rate 0.15 and discount rate 95%. Okay. And here, so here is probably the part that LLM agent we are calling for the agent that's being initialized, and then we start the simulation. Here's the state we initially pick, and then here each agent chooses the action, and then based on that action, there will be a price coming out, and then the profits will be divided because of the number of customers they get is fraction of customer they get is different. And then that's the next state gets us to the next state. And the Q updates will be based on the profits as a reward function and do the deep Q learning to update the Q table and update the next state. Okay, so we keep doing that. And here we run the simulation. Okay, so here it is. And if you want to plot it, so you can just plot it. First, the prices. So the prices initially went over and relative to the Nash and monopoly prices, the prices are a little higher set, and hence the profits are not optimal, so the profits are slightly lower. Okay. And as a demo, we can also try an impulse response. So if one agent A deviates, how does that settle? And you can see that they initially deviate, but then get back to where they were. Okay, all right. So this is to illustrate how to do algorithmic collusion using OpenAI API-driven LLM agents. Thank you for watching this episode.